Hey everyone, and welcome back. We love digging into the latest in AI, and today's deep dive is no different. We're jumping into the world of AI voices. How do you make them sound less robotic and more, well, human?
It's a question researchers have been wrestling with for a while, and it's led to some really cool breakthroughs. Today, we're going to take a closer look at a new system called F5-TTS. Claims to be a real game changer in the field.
A game changer, huh? All right, you've got my attention. I think we've all had the experience. You're listening to an AI narration, and it's just lot off, a little too robotic, a little too monotone. Like listening to a very polite robot reading a grocery list.
Yeah, that's a pretty accurate way to put it. It really comes down to how traditional text-to-speech systems work, TTS for short. They typically break down language into those individual sounds, phonemes, and then try to piece them back together. It works, but it often lacks that natural flow and rhythm of, actual human speech.
So it's like trying to recreate the Mona Lisa, but you've only got these tiny square tiles. You might get the general picture, but the brushstrokes, the emotion, it's just not there.
Exactly. Plus, those traditional systems, they can be slow, especially if you need to generate a lot of speech. Can you imagine having to wait like hours for your AI assistant to read you a short article?
Oh, the humanity.
Yeah.
We need instant gratification. So how does F5-TTS fix these problems? What makes it so special?
So instead of piecing together speech like a puzzle, F5-TTS takes a totally different approach. It uses something called flow matching.
Flow matching. That sounds kind of intense, like some next-level martial arts or something.
Yeah, well, maybe not quite as action-packed, but it's definitely elegant. Imagine you've got a chunk of clay, right? And you want to sculpt it into this amazing statue. Flow matching is like having these mathematical instructions that guide your hands, slowly shaping that clay into exactly what you want. Except here, instead of clay, we're talking about sound waves.
Okay, so instead of chipping away at marble, F5-TTS is sculpting sound waves into words and sentences.
You got it. It starts with random noise, think like static on a radio, and then uses flow matching to gradually refine and shape that noise into recognizable speech.
Wow. Okay, my mind is kind of blown right now. It's taking this jumbled mess of sound and using math as its chisel. It's creating a human voice.
Sounds crazy, but it works. And here's where it gets even more interesting, this whole process. It happens in parallel. The entire speech segment is created, like, all at once.
Hold on, did you just say simultaneously? As in all at the same time?
Yep. Unlike those older systems that generate speech bit by bit, flow matching lets F5-TTS create the whole thing in one go, which makes it way faster.
Well, now you're speaking my language, speed,
Yeah.
but how much faster are we talking?
So the research paper mentions something called the real-time factor, or RTF, of 0.15.
RTF. Is that like one of those acronyms only engineers understand? Break it down for me. What does an RTF of 0.15 actually mean in real life?
Basically, it means F5-TTS can create speech way faster than real-time. Imagine creating a 10-minute podcast episode, the whole thing, in the time it takes to make a cup of coffee.
Wait, seriously, I could have a whole episode ready in the time it takes to make instant ramen. That's insane.
That's the power of flow matching and parallel processing for ya. But speed isn't the only cool thing about F5-TTS. It also tackles another big issue in speech synthesis: text-speech alignment.
Alignment. What does that even mean in this context?
It's about making sure the generated speech lines up perfectly with the text input, both in terms of timing and pronunciation. See, in non-autoregressive systems like F5-TTS, where you're generating that whole speech segment at once, getting that alignment right can be tricky.
So it's like trying to sync up a movie soundtrack with the action on screen, but you're doing it live, without knowing how long each scene should be.
That is a perfect analogy, and if that alignment's off, you just end up with this jumbled mess of words that don't make any sense.
So how does F5-TTS crack this synchronization puzzle? What's the secret?
Well, this is where it gets really interesting. F5-TTS uses a technique that at first sounds kind of counterintuitive. It adds filler tokens to the text.
Filler tokens, is that like
Yeah.
leaving the blank spaces in a crossword puzzle? What do these filler tokens actually do?
Think of them kind of like musical rests, in a piece of sheet music. They don't actually represent sounds themselves, but they tell the system when to pause, how long to pause, helps create that rhythm and flow.
Oh, so it's like teaching the AI the art of silence.
Yeah.
Clever. But how does it know where to put those rests in the speech.
That's the cool part. Instead of relying on some super complex algorithm to try and predict pause placement, F5-TTS just learns directly from the data. During its training, these filler tokens, they're strategically put into the text, and that lets the system start to connect those tokens with natural pauses, those inflections we have in human speech.
So it's like giving the AI training wheels. Instead of having to figure out the timing and delivery on its own, get these little hints to help it sound more natural.
Exactly. And get this simple trick, these filler tokens. It leads to some pretty huge performance gains.
All right, like what? Don't hold out on me.
Well, remember how we were talking about F5-TTS using those ConvNeXt V2 blocks to analyze text?
Yeah, those things sounded intense.
Right. Well, those blocks, they actually work together with those filler tokens. Think of it this way. Before F5-TTS even tries to create any speech, it looks at the text almost like a musician reading sheet music, right? It's analyzing the rhythm and the flow of the language, where those natural pauses should be, where to emphasize.
And those ConvNeXt V2 blocks, they're like the AI's sheet music readers.
Yeah.
Helping it understand how the language is supposed to sound.
Exactly. And once it's got a good handle on the structure of the text, then it can use those filler tokens or like guideposts to make sure the generated speech has that nice natural flow.
So it's about teaching an AI to be more than just a narrator. It's about being a storyteller, understanding the music behind the words.
Nailed it. And the results, they're pretty amazing.
Okay, so we've got the speed, we've got natural sounding speech. What else does F5-TTS bring to the table?
Well, on top of those things, F5-TTS has another big advantage, robustness.
Robustness. Is that like AI speak for being tough?
Pretty much. Basically, it means the system can deal with unexpected input or challenging conditions without, completely falling apart.
So kind of like an off-road vehicle. Throw anything at it, rocky terrain, steep hills, it can handle it.
Great analogy. And just like a tough off-roader, F5-TTS is built to navigate let's say, the bumpy terrain of human language. It can handle different accents, dialects, maybe even speech impediments, all while still sounding clear and natural.
Okay, that's really impressive. But what makes it so adaptable? Is it those filler tokens again?
They definitely play a role. But it's also about how F5-TTS is trained. The researchers used this huge data set of multilingual speech called the Amelia dataset.
Wow.
It's got tons of different voices, accents, ways of speaking.
So they basically put it through a linguistic obstacle course, exposed it to all kinds of language patterns, just to make it as adaptable as possible.
You got it. And by training on such a diverse data set, F5-TTS ends up with this much more robust, more adaptable speech model one that's not going to get thrown off by an accent or speaking style it hasn't heard before.
Wow, that's really cool. So it's not just about sounding human. It's about sounding human in all the ways humans actually sound.
Exactly. And that has some really big implications when it comes to accessibility, right?
Accessibility. How so?
Imagine people with speech impairments could use F5-TTS to communicate, but with their own personalized voices. Voices that sound just like them, no robotic or artificial sound. Or think about educational tools that can adapt to different learning styles, a more inclusive and engaging experience.
Wow, those are some really powerful applications. It's like we're not just talking about improving how AI sounds, but also how we can use this technology to make the world more equitable and inclusive.
Absolutely. And that's why robustness is so important when developing any AI, especially when we're talking about something as fundamental as communication.
This is incredible. We've gone from robotic voices to AI that can handle accents, dialects, maybe even beatboxing someday, right?
Well, I don't know about beatboxing just yet, but yeah, the progress is really something. Makes you wonder, where does AI speech synthesis go from here? What's next?
That is the million-dollar question, isn't it? What's next on this wild ride?
One thing researchers are really interested in is emotional expressiveness. Like right now, F5-TTS, it's amazing at neutral, natural-sounding speech, right? But what about those more subtle human emotions? The joy, the sadness, even sarcasm.
Ooh, that's the tricky part, right? Like, I can tell my AI assistant to say something sarcastically. It just sounds like it's reading a dictionary.
Exactly. Getting an AI to not just understand, but actually reproduce those emotional nuances in speech, that's a huge challenge. It's not just the words, but the tone, the pacing, even tiny inflections, they all carry so much meaning.
It's like teaching an AI to be an actor almost. Deliver a line with just the right feeling, the authenticity.
Right, and that's a field that's just getting started. But imagine, in the future, you could have an AI companion that's truly empathetic, one that not only understands what you're saying, but how you're feeling, and can respond accordingly.
That would be amazing. Although, I can also see how it could get a little, I don't know, A little too real.
Yeah, I see what you mean.
Like, what happens when your AI therapist starts sounding more human than your actual friends?
That's definitely something to think about. As we keep pushing those boundaries between human and artificial intelligence, we gotta be really careful about the ethical side of things. Just because we can create something doesn't always mean we should.
Like they say, with great power comes great responsibility, right?
Yeah.
We got to make sure we're using this technology for the right reasons, not just, to build robots that can perfectly mimic every human emotion.
Absolutely. And that's a conversation we need to be having now, not later.
Right. For sure. So we've got more natural sounding voices, more emotional intelligence on the horizon. Anything else in store for the future of AI speech?
Well, I think personalization is going to be huge. Imagine your AI assistant, your GPS, even those characters in your video games all have unique voices tailored to you.
Okay, now you're reading my mind. I've always wanted Morgan Freeman to narrate my life.
Haha. Well, hey, you never know. But seriously, this level of personalization, it could completely change everything from how we learn to how we have fun, even customer service.
It's like having a whole world of voices at your fingertips, each one ready to talk to you in a way that feels both familiar and engaging.
Exactly. And that future, it's closer than you might think. F5-TTS and other systems like it, they're leading the way to a future where AI voices aren't just tools anymore. They're companions, collaborators, maybe even muses.
And to think, it all started with a pretty basic question. How do we get AI to sound less robotic?
It just goes to show sometimes the most groundbreaking stuff comes from asking those simple questions.
So true.
And on that note of boundless possibility, I think that's a wrap on our deep dive for today. But before we go, one last thought for you, dear listener. As AI voices become more real, more advanced, more woven into our lives, how will you choose to interact with them? It's something to think about. Thanks for joining us on this journey into the world of AI speech synthesis. Until next time, keep exploring, keep asking questions, and most importantly, keep listening.